Hello viewers, today I am going to design a G+9 RC frame shopping mall using stats. You can see the plan of the shopping mall here. In this plan, this is the stair block, it is food court, this one is lift block, here toilet block. The middle portion are corridor and remaining upper three and lower three, those are different kind of shops. And this is a G+9 shopping mall where the ground floor height is 4 meters and remaining 9 floors the height is given here, the floor height. As per my roll number I have to select the floor height. In this plan some dimensions are given as A, B, C, D, that is also designed as per my roll number. So here you can see that the data to be selected considering last two digits of my examination roll number, which are 1 and 6. The second digit is 6, so according to the second digit, my A will be 5.2 meter, B 3.5 meter, C 6.6 meter, and D 6.3 meter. And according to first digit, as 1, my floor height will be 3 meter and the location of the shopping mall I will consider Vizag. So again let's go to the plan. First of all, I will create a single node at origin. The origin will be 0, 0, 0 point and that origin will be this A1 point. Using this only single node I will create the whole shopping mall. So let's go to stats. So okay. The file name I have already written as G+9. Location is also selected. Type of the structure will be analytical. Unit is metric. Now I am creating it. So as I have mentioned that my first node will be 0, 0, 0. So here I have pointed out the first node and this is my 0, 0, 0 node. Okay. The remaining nodes I will design in this direction. Instead it will be z x direction and this direction will be z direction. In x direction I will input another 4 nodes which are at equal distance of D. So let's see the value of D. For 6 the D value is 6.3. So let's put, at first I will select the node, will go to geometry, translation and repeat, and in x direction the distance will be 6.3 and the number of steps will be 4. And another thing I will do here, that I will click on this link step. It will help me to join the nodes using beams, and I will click here on OK. So you can see that in each direction those beams are created. For ease of drawing I will go to the top view, and the same thing I will repeat in Z direction. For that I will select the beam cursor and select all the beams, and let's check the dimensions again as it is given A, B and C. So let's put the values. according to my roll number, A is 5.2, B is 3.5, and C is 6.6. So let's put those values. I have selected all the beams. We'll go to geometry, translational repeat. Now it will be in Z direction. So I will change the direction. Global direction will be Z, and the number of steps will be 3. And here I will not uh, write the spacing here because my three spacings are different. The first spacing is 5.2 meter, second one is 3.5 meter, and the third one is 6.6 meter. And I click on link steps to create the beams in Z direction, and will click on OK. So you can see that my plane dimension I have given here, and this is the plane view. And one thing that let's go to utilities, node tools, and node to node distance. Node to node distance. This one is 6.3 meter. This one is 5.2 meter. And here this one is 6.3 meter. This one is 6.6 meter. So by seeing this, you can understand that the column to column distance are quite high. So in that case, I have to provide some secondary beam here that I will do later. At first, I will create the whole model. For that, uh, okay, this is my ground level, and in y direction, I have to make it g plus 9. So I will select all, go to translational repeat, and as it is g plus 9, so I will put the number of steps as 10, and default spacing will be 3. But the ground floor is 4 meters, so I will change here only the 4 meter. Remaining will be same. And again I will click the link step. Here link step will help me to create the columns, and I will click on OK. So definitely we have understand that what mistake is there. That I have created the whole thing in X direction, but it should be in Y direction. So I will do that again. Will select all the beams, go to translational repeat. The number of steps will be 10. The distance will be 3, but the first floor will be 4 meter, and will click on links, and here I have to change that the global direction will be Y. Now it will create all the floors where the link steps will help me to create the column. So okay, here my G plus 9 is created, but this is my ground level. From ground level 1.5 meter below, I have to create the foundation. Here the foundation will be pile foundation. So at least up to pile cap, I have to extend my column. So for that, I will go to front view and select the node cursor and we'll select all the ground floor nodes, and that I will see by isometric view that all the below nodes are selected. Then I will go to geometry, translation and repeat. In y direction, number of steps will be 1 and the default step spacing will be minus 1.5. The distance is 1.5 meter and I have put it, the minus sign as it is in the below direction. Again I will go to view, front view, and will select only the ground nodes and will click on link state. I have selected only the nodes because if I select the beams there, then the beams also will be repeated. That is not required here. So I am clicking here. You can see the I have reached the foundation height. So I will go with the isometric view, and here the columns are created, and the pile cap will act as fixed support. So I will give the support here. We'll go to support and view will be front view. Here I will select all the below nodes and here create a fixed node. As I have selected all the nodes earlier, so without adding here I will directly assign. So you see here that all the fixed supports are assigned here. Let's see in the isometric view that all the supports are assigned. Now I will create the secondary beams. For that I will go to front view and select, okay, this is my ground level and this is my first floor base level, and I will select this only. Okay, so the node cursor is selected. I will take the beam cursor. I will select all the beams here. All the beams selected. Let's see again in the isometric view that all the first floor beams are selected. And the view here I will check on the selected object. So which objects I have selected, only those objects will be visible. And I'll go to top view. And here I will add some secondary beams such a way that the effective length of the slab will reduce. So for that, I will go to geometry, add beam, and from here I will add midpoint beam. Here, here. So for adding midpoint beam, I will just click on the beam. So it will automatically detect the midpoint. So randomly I am doing this. Okay. So the secondary beams are created, but here the secondary beams are act as fixed beam, but it should be simply supported beam. So for that, I have to release the moment at each joint. So for that, I will select all the secondary beams one by one, and I will go to specification. Here, I will click on beams, and the member specification in release, the location is start. I will release the moment mx, my, and mz, and I will click on assign at start. Okay, so at the start point, the moments are released. Again, I will go to beam, look, release, location will be end. Again, we'll click on mx, my NZ. So all the movements from end will be released, assigned. So you can see that here the movements are released and here also movements are also released. Now I will go to view and display whole structure. But before that, I have to make its translational repeat in each floor. So I have selected all the beams and click on display whole structure, and we'll do the translational repeat of this in y direction. The distance will be 3 and number of steps will be 9. But here I will not click on link step. If I click on it, then it will create some extra columns which are not needed. So here all the secondary beams are created. For today up to this, again I will discuss in the next video regarding the Mumty room, the stair half landing and the lift block. So today up to this.